To attain measures of technical and competitive activity which, if not statistically verifiable, may help focus attention on underlying trends. Okay, that's it. That's what we do. And we also are mostly statistically relevant these days too, because we have huge data sets, and we're taking very rigorous steps to analyze it properly. So this is back in 1987. Then my all-time favorite quote, okay, my all-time favorite quote, and I got hassled so badly because I stood up there in 2003 and said, hey, I was born in 1966. And so when I was born, people were talking about this. So every speaker after me got up and said, well, I was born before 1966, or, well, I was born after this. Everybody made fun of me because I was talking about when I was born. But I love this. We have the choice of using pad statistics cautiously and learning what we can from them, or not using them and learning nothing about what they alone can teach us. Okay, if you want a mission statement, if you want to know exactly in one pithy sentence exactly what you're doing here, that's it. Okay, you can either not use it and not learn anything about what it alone can teach you, or you can use it cautiously and correctly. And that's been the journey ever since, is to evangelize and to talk about how is it that we can use this better? How can we use this data properly? How can we comfortably provide insight that we can stand behind and that we can back up with evidence and data? All right? So, I suggested to a cynical audience, and I got to remember, in 2003, they thought I was nuts at PIEG. I'd only been a member for a few years, and like, who is this guy? Where did he come from? Who the hell is he? Why is he saying all this? I'm just a patent searcher. Just let me get back to searching Derwent codes and Derwent fragment codes, and just leave me alone. Okay, what's all this analysis nonsense? Well, I suggested that, well, this might be the future of the field. That this was where everybody was going to be going. Now, let me preface that. I got my start as a patent information searcher or finder, professional, whatever. And the absolute very first step in building any sort of analysis project is to put together the correct collection. Okay? If you don't have the right collection to start with, the analysis is crap. It's absolute rubbish. Okay? There's no point. And so if you can't generate a good collection, a proper collection, and then manipulate it, standardize it, et cetera, to put it into a proper form so you can get real insight, the rest of it is just rubbish. It's just not worth doing. So I have a tremendous respect and a great admiration and a kinship. So this was never meant to say, well, there's not value in patent information retrieval. Of course there is. It's essential. It's impossible to do the next steps without that step. So what was also interesting is at the time, one of the other major pundits or one of the major figures in the patent information world said this: experienced users have a certain degree of prejudice against analysis tools. And boy, can I tell you that's true. It certainly was back then. It's possible to conceive of a worst-case scenario in the use of analysis tools. The tools are just as capable of drawing an exquisite map, graph, or diagram in the hands of an untrained user. What I'm arguing for is active involvement of specialists in the development, marketing, and utilization of these tools at all costs. And then my question is, 18 years later, is that how we still feel? Are we there? As more and more end users are doing their own patent analytics with a variety of other tools that are available on the market, where do we stand in this regard? And what is it that we're going to do to make sure that the people that we work for and the work that we do gets the proper recognition? Because quite frankly, if I had a nickel for every crappy patent landscape that I've ever seen, I wouldn't be here. I'd be on a beach somewhere. I'd be retired. And it's gotten much, much better. But there was a time where and Raj mentioned it in his talk, you just couldn't tell whether or not, or you just didn't know whether or not you were getting a load of nonsense, or if you were really getting results that you could verify and that you could actually make important strategic decisions based on it. So that's what we were. Now, these are some questions that I thought I would talk about a little bit. Basically, how did this all work out? Has patent analytics arrived as a recognized discipline? This is an absolutely unquantifiable yes. Okay, I mean, now, while we're still experiencing some growing pains and we're not terribly well organized, as a group, we are absolutely recognized and valued. And on top of that, we have managed to come up as a community with guidelines, with best practices, with the ability to work with one another. We've had influence on the tools. We've created an environment where we can be pretty rigorous. Professionals who understand what they're doing. For instance, something really simple. Okay, how many people outside this room that are interested in patent information can tell you what a patent family is? Okay, just about the simplest thing we do. But if you don't do it right, everything else is wrong. All you're counting is which company is bigger and has the bigger patent budget. Okay, so you have to reduce it by patent family or everything else subsequent to that, all the numbers. I'm reviewing a paper right now for World Patent Information, and this person wants to argue with me about, well, we don't need to do a patent family reduction with our results are okay without it. I'm like, what are you, nuts? You're talking about who's bigger than who. And how can you talk about who's bigger than who unless you've done a reduction and gotten to the inventive concepts as opposed to the raw number of patent documents? Does patent analytics provide significant value for the patent information field? Absolutely. No doubt about it. Does it provide significant value for the world at large? Absolutely. The country of Singapore, just as an example. And what we're seeing with all the world's patent offices. There is absolutely no doubt that the world is on board, that everybody is beginning to really understand what it is we do and why it's important. But then that starts to ask some of these other questions. How many of us believe that specialists will still be doing patent analytics 10 years from now? Okay? How many people in this room are going to be doing what they're doing today 10 years from now? Okay? And that's the last part of the talk. If so, what will that position look like and who will be doing this type of work? All right? Something to think about, something to anticipate as we continue along. And this is that second slide about imitation being the sincerest form of flattery. And it just gives a couple of more examples. That talked about the UK Patent Office, the Singapore Patent Office, the Australian Patent Office, the European Patent. All of these produce landscape reports now. Every single one of them. There's a pretty popular magazine in US and Europe, I think, and they've done events here. IAM magazine, Intellectual Asset Magazine is what it stands for, or Intellectual Asset Management Magazine, IAM magazine. And they've even got their own data analysis blogger. And they've worked with several organizations here in India to produce short articles talking about emerging technologies. And this is an organization that is primarily, it's a little bit like in the United States and other parts of the world, some big companies have this thing called the Intellectual Property Owners Association, IPO. And IPO is tremendously interested, and IAM is mostly made up of people that would be part of IPO. They're the chief patent officers or the chief information officers of their companies. What was exciting for me is that, yes, I generated this quaint little report on quantum computing a few years ago. And once upon a time, I did a case study on Jawbone versus Fitbit. And that was a great case study because I actually predicted that Jawbone would buy Body Media. So 2 weeks before the acquisition actually took place, I suggested that Jawbone needed to buy patents from somebody, and I suggested Body Media was the best candidate. And then 2 weeks later, me having no involvement at all whatsoever, they did. They bought the company that I suggested. Okay, and this was all verified, it was all published, so I called my shot. And I decided I wanted to do another report where I would start calling shots about an emerging technology. And I'd always been fascinated in quantum computing, and there's a phrase, the technology of the future and always will be. Okay? People talk about fusion, nuclear fusion that way. It's the technology of the future and always will be, because we can never quite seem to get up over that technology plateau in order to start implementing it. Quantum computing has been like that. Quantum computing, Feynman talked about quantum computers back in the 60s. Okay, this is not a new concept, but it's only been in the last 10 years, or basically even the last 6 years, that we've gotten up over this technology curve and that it's now becoming likely that we will have practical quantum computers in the next couple of years, and have already achieved quantum supremacy in some degrees with the Google machine that's apparently 52 qubits. So I decided to go ahead and do a landscape on quantum computing before anybody else did. And I made some predictions in that report. Now, the primary prediction was, as it turned out, that look out for China. Okay, that this is going to be a huge battleground. This is going to be a huge deal where the US is going to be watching China and everybody else is going to be watching China, and look out for China. Well, that got to be so popular that it was articles were written in Wired, MIT's Technology Review magazine, Bloomberg, and then the Washington Post. So this is our profession being recognized and being valued and being discussed by some of the world's largest culturally significant media outlets. Technology Review is the only one of these that's really technology focused. Okay, the rest of them are all popular press. And yet they were very excited and very interested to grab hold of that story and to tell that story based on patent analytics. Okay. I don't want to spend a lot of time on this, and it's part of what I wanted to ask the audience as far as what's India going to do. So the people in this room, how are you going to be perceived around the rest of the world? And what role are each of you going to play in this emerging, changing field that we're involved in? And part of that is this idea of professional certification. And the thing that's a little bit funny to me is that we still haven't exactly come to terms with whether or not patent analysis is going to be part of the QPIP exam, which I think is utterly preposterous. I don't personally think you can call yourself a patent information professional today and not have some experience, or at least some basic ability to conduct an analysis report. Okay, and as if and when the certification process continues, and how exactly that plays out here in India, if it plays out at all, I think it's important to keep that in mind, and to actually put some pressure on the organizers to make certain that patent analytics is included, because quite frankly, more and more of us are being asked to do this more and more frequently, and as I'm going to talk about at the very end, machine learning technologies are going to make some of the patentability type work, for instance, probably a little less, done a little less frequently by people like ourselves. All right. I just wanted to throw up a few visualizations. I mean, like I said, that this talk is kind of broken into 4 or 5 pieces. This is one that we've been working with for decades. This is not a Themescape map, because Themescape is trademarked. But just about every single platform these days has what I refer to generally as a spatial concept map. But how many of us really know how to manipulate this visualization and tell a coherent and valuable story based on its output? For quite some time, or at least in the early days of this profession, there was an emphasis on visualizations. And I worked at Origin Systems, the original Themescape company. And that's what they would do. They would go in and say, hey, look at this great map. Well, nobody could really explain what that map said. Nobody could really explain how that map was generated. But gee, doesn't it look good? Okay? And so my whole point in showing some of these things is that these visualizations are critical, but they don't take the place of a trained analyst who's telling the right, who's providing insight. The visualization is not the insight. Your interpretation of the visualization is the insight. And this is the one for quantum computing, and it actually worked out really well. It separated out the qubit from the hardware, from the applications, and I could tell you exactly where D-Wave was versus IBM, Microsoft, and Google, the 4 biggest players in the quantum computing field. This map was particularly useful in driving home the conclusions and the insights I was drawing from the quantum computing report. This is an eyesore. Yeah, this is an eye chart. We refer to these as. A lot of data. But there's ways to make this data pop out, like these red boxes. These red boxes are who are the people that have been most influential over the last 3 years. This provides information about, well, how much is granted, how much is still in application. What's the trend over time for each individual row? This is stacked information. This is layered information. This might have been represented in 4 or 5 different charts or 4 or 5 different slides previously, and it would be difficult to provide any context about any one portion of it. But when you see it all together, it really sings. It really tells you, like for instance, magic. And this is funny too, because these guys have since gone back up. They got out of it, and now they're back into it as the field has grown more popular. They were early innovators. The market wasn't ready yet, and now they're back. But you would look at this and say, well, these guys are in the top 10. Well, at that time, they hadn't published anything in the last 4 or 5 years. So even though you're in the top 10, that doesn't mean you're still relevant. Okay? But the fact that they resurged again meant that it was important that they were in there in the first place. I really like these sunburst diagrams. These are really great ways to look at. One of the things I do at Patinformatics is I have something called a stat sheet, which is a little bit like it's a single page that tells a story of a company or a technology, things of that nature. And one of the key portions of the stat sheet is actually one of these sunburst diagrams for each company. And so you can look at tens of thousands of patents and break them down into these categories and subcategories, and in a few moments, even to a greater degree than what you would get with a themescape map or a spatial concept map, you can get a really good idea about how much interest an organization has on a specific area or sub-area. So that's a sunburst diagram. I really like those. This is a really cool one because it actually compares. One of the things I said in the report is if anybody wants to compete with IBM, they might be interested in acquiring Northrop Grumman. And what this does is it looks at here's IBM, here's Northrop Grumman, here's hardware versus hardware, and then the hardware components versus their hardware components, and the qubit generation, what they're interested in, the qubit generation, and what IBM's interested in one picture. This provides, now, there's other visuals that would work with this, column or stacked, clustered or stacked column charts, but they can only work with a certain number of variables. And the sunburst can work with, you can have layer upon layer upon layer if you really wanted to. So I like those. And this is something that I think is coming. It's available in some of the tools. I think someday this is going to be available in all the tools. People have been looking at hyperbolic trees in patent citations based on a linear progression, a root patent, and then everything that goes out backwards and forwards from it. That was something Orica had in the very early days. But that doesn't really give you the whole picture because these things don't exist in a vacuum. You're not interested generally in looking at one patent at a time. You're more frequently interested in looking at an entire network. And so this is a patent citation network of the quantum computing space. And the really interesting thing is, yes, you do see IBM there. Yes, you do see D-Wave. You see Microsoft. Google, at that time, didn't have a lot of publications, and they're not all that prevalent. But you see these big citation nodes for HP and for Northrop Grumman. And again, that was part of the analysis that actually led me to the insight that keep an eye on Northrop Grumman. All right? Nobody had heard of Northrop Grumman in quantum computing. Okay? And I think in the next year or two, next couple of years, they're going to emerge as a major player or an acquisition target. So I'm calling my shot. That if you someday read the paper about how the Northrop Grumman quantum computing assets had been sold to, any company, that you'll know where that came from, because those assets are actually very, very good, and they're very well thought of from a citation analysis. Okay, next part of the presentation, and this is really where this is all headed. Okay, those questions about what are we going to do, and as far as representatives from India and the country as a whole, what is it that we can expect where the industry is going to be going, And what is it that you can do to be part of that? So when I was asked to do this particular portion of this presentation, what they asked is, okay, if you broke down the steps in preparing a patent landscape report into the different sections, where could machine learning technologies make an impact or play a role in those particular sections? So I started with building a collection, which is primarily conducting the search and determining relevance. This is clever. Tidy is an R library. And it's an R library that's used for data cleanup and standardization. Okay, so I'm playing off the idea that anybody who knows R would have recognized the Tidy library and what it does, and this whole idea of using R and machine learning and various semantic analysis techniques is where this is all headed. And so that includes your patent family reduction, deciding on the type of year, standardizing key fields, and creating categories. And then you analyze the collection, visualize the collection, and I already talked about the visualization part, and then of course sharing the conclusions. And so if you start to look at this, and I won't read this, I'll leave it to you to look at offline, but the idea is that I like the idea of separating precision from recall. Okay, I like the idea of using one type of technique to increase my recall, to find as many likely relevant documents as possible, even if I overshoot what's actually out there. And then in a second step, using a different machine learning technique to increase my precision. So that in the end, I've got a collection that is both comprehensive and relatively clean. And what I've said in the guidelines and what I've said all along is that from a practical perspective, if the level of recall can be established at higher than 90%, while the precision kept above 70, then the likelihood of finding statistically relevant but conceptually irrelevant items in the subsequent analysis is reasonably small. Bottom line is, with 90-70, most of your major trends are actually going to be major trends that are actually relevant. There's a small likelihood that there's going to be enough noise in that 30% that's going to bring it to the level where it actually shows up as a peak somewhere. Okay? So here's just a few examples. There's a cosine similarity algorithm. There's latent semantic analysis. There's more like this. And Google has even put together a blog post about how they're expanding their patent sets with machine learning and BigQuery. So Google has already come out and provided basically step-by-step instructions and material on GitHub that anybody can download, and free data available in BigQuery that allows you to take advantage of these machine learning algorithms to increase their coverage, to increase their comprehensiveness when they're putting together patent collections. And then determining relevance, I'm a big fan of support vector machines, vector space models, neural networks. There's lots and lots of different algorithms that are out there that could, once you've got a comprehensive collection, you can then fine-tune it so that you increase your precision and you can create a collection that is then statistically relevant for analysis. From a timing perspective, I think I'm still doing pretty well. So, but I think I want to wrap this up in 5 minutes so that we can get to some questions. I don't think any of this is a surprise to anybody. That as good as the databases are, there is still some need for patent assignee cleanup. Okay, they're getting better, but you still have to double check on a few things. We still have to do patent family reductions. The industry is starting to land on simple families as a means of doing that. I think that's great. It's not what I actually use myself, mostly, but for goodness sake, don't use Impodoc, all right? That's the other one. And for decades, well, for years, I suppose, and it really was decades, all those whiteboard reports, for instance, are all based on Impodoc patent families. Impodoc patent families are the worst. Okay, they're horrible. Okay, and I've shown example after example where a company that has 30 unique US inventions is represented by a single Impodoc family. It's just US practice that they write these omnibus, these huge specifications, and then they just go continuation, 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 divisional, divisional, divisional. And all that inventive output, that was part of the Jawbone Fitbit example. Jawbone, if you looked at their portfolio by Impedoc family, they have one family. Okay? Meanwhile, if you looked at the number of US applications, there's like 35. And they covered all sorts of different things: power management, device control, undermolding, overmolding, all these disparate individual technologies, but it was all part of one family just because of the way they wrote the patents. Okay? That's just wrong. To say Jawbone has one inventive concept is just wrong. Okay? Anyhow. And then we can also use some of these binary classification methods and various machine learning algorithms of different types, and whether they be, neural networks, black boxes. There are very good ways, or ways are being developed to create categories. Because really, that's really the secret sauce of any good landscape report, is not just that you know how many documents from how many companies, but you actually know which companies are working on which things. So when I did the quantum computing, I wanted to make sure that there was a distinction between the people that were working on qubit-related technologies versus other hardware, versus applications, versus cryptology and other sorts of downstream applications of a quantum computer. And if you don't create good categories that are business relevant, well, then you really can't make meaningful comparisons and provide insight. And then there's Python. So how many people in the room are using Python right now? There you go. There's the guy. He's the guy. Talk to him. You know what? I do this thing for one of my clients where I look at an alert. So I get documents every week, and I look at them, and I've got this whole system worked out for how to do them. And at the last step, the very last step, I have a list of terms. And these terms are in categories. And I've got this Python script that a friend of mine helped me put together that will basically go through and look for what at this point is about 300 different terms. And if any of those terms show up in the text that I feed it, it comes back. So those things that I was prepared to discard, I run through this. And then invariably, maybe 5 to 10% of the things that for whatever reason, on first glance, it didn't look like it might be relevant. But with a more thorough examination with a lot more terms, it popped up. I took a second look at it. I ended up including it in my collection. Okay? All of these things are going to be part of what we do in the future and how we continue to develop collections that are going to be relevant and on topic. And finally, very, very, very lastly, before I open up for questions and also make some a challenge to the Indian community, I've also gotten involved with this idea of creating gold standard collections. And this is actually a much larger presentation that I'm not going to go into. And the bottom line is that it's up to us to get involved with working with machine learning technologies, or take our chances with what they come up with on their own and what they go and tell our clients about, and explain to them about how they don't need us anymore because they can use that instead. Okay, that's reality, folks. I'd love to paint it some other picture. But I watched it happen. I worked at Chemical Abstracts. They developed this nice little tool called SciFinder. They had no idea what SciFinder was going to do to the chemical information profession, which has essentially decimated it. Okay? There are still chemical information professionals out there that do chemical information retrieval for a living. They are strictly looking at patents and marquoosh and various complicated, patent-related items. They don't, bench scientists don't ask for chemical information searches anymore, at all. Okay, SciFinder is so big that they can't sell it anymore. Okay, they've saturated the market. Every university, every big company, the vast majority of the research chemists in the world have SciFinder on their desks. Okay, and I worked at Chemical Abstracts 20 years ago when they first brought that product out, and they had no idea what they were going to do. We are in that same type of situation. these new technologies are going to be the sci-finder for our profession. All right, so we can either be on board and be better at using them than anybody else, or we can get swept away. All right, and I believe that very strongly. Just as strongly as I believed 17 years ago that patent analytics was the future of the profession, I am certain now that machine learning technologies are going to end up playing an amazing and essential part in how we do our jobs or how our clients do our jobs. Okay, but the bottom line with this part of it is that they need standards. They need, and to develop a standard helps you to recognize how these things work and how you can best take advantage of them and how you can best use them yourselves. And so here in the next couple of months, I'm going to be starting an initiative where I'm going to be asking for assistance. And I'm going to start working with hopefully most of the major patent machine learning companies to talk about promoting the field and talk about how it is that we can make sure that the field grows and evolves the way that we want it to, as opposed to the way that they end up being able to do it by chance. And that's where I'd like to ask for your help. As you hear about this developing over the course of the next year or so, if you have an interest in helping and participating in this consortium, I'll be looking for people to assist. And with that, I will take questions.
Tony, it was really fantastic listening to your, this is my first, viewing your presentation. It was really eye-opening. My quick question is, classification system that we currently have for classifying patents, these are basically the genesis comes from the library classification, or it is basically an enumerative classification, which is basically we list all the classification for all the entire science and technology, for all kinds of technologies upfront. Don't you think this is not the best for classifying something which is evolving so fast, patents, whereas this was originally developed for a relatively slow-moving organism like books? So isn't it time to have something which is more exciting? And for example, there is e-commerce sites like Amazon, they use something called as a faceted classification. Mm-hmm. So is it time to also look at new ways of classifying patents, at least to begin with?
And that's an amazing example of what it is that I'm talking about. That's where we add value. That's where our profession can help drive and direct things, because we understand the technology. We work with the companies. We know the most important thing to do in a categorization is understand what matters to the company that you're doing the report for. Okay, I would love to be able to use CPC codes exclusively to create categories. It would make my job a hell of a lot easier. Okay, but unfortunately, the CPC codes don't map directly to what my clients want to know. Okay, so those pivot points, those areas of additional insight, or that context isn't available from that classification method. So I have to create my own. And if I create my own based on individual search queries, if I create my own based on doing a word map and looking at what pops up as to what are the most important things that I need to make sure I get covered, there's a variety of different techniques. And the ability to remain flexible and the ability to quickly change direction and develop new categories is absolutely essential. So unequivocally, yes.
Tony, as a continuation of this, what about creating a concordance between CPC and SIC?
Well, okay, so what is SIC?
Standard Industry Classification?
Yes, and that's what I thought. So it's, you know what, that's one of the biggest challenges. And again, if somebody, you know, and I actually just read, I mean, just recently, within like the last 2 weeks, there was a European Patent Office research project that looked at patents to products, okay? And that's always sort of been a bit of a holy grail in this industry. Is like, well, yeah, we know there's so many patents out there, but how much does a company actually, what percentage of the things they patent actually go on to become products? And if you can predict that reliably based on historical data, that's extraordinarily powerful. So I think so again, I would suggest, having a look at the EPO website. They talk about their current batch of research projects from 2019, and the official reports and the papers and the data sets that were used. And I think that is coming, and that's an opportunity for various database providers to merge those things and to come up with an added value that I think the entire industry would find very, very useful.
I have two questions actually. One is on the certification, Patent Information Professional Certification. I've been a member of PIUG for over 15 years now, so I'm aware PIUG has been doing a lot of things, but that's limited to US. We still do not have anything internationally where we can say we are a patent professional or we are a patent information professional other than the legal whatever we have in India, patent agent, in US we have something else. So it's something, it's not, I know PIUG has been discussing this for quite some time. And we did start something on certification, but it's not gone the way I would have liked it to go further on an international platform. So there is one question, is there any thought on that? And secondly, for the sunburst diagram, I'm just curious, was there any particular technique that you used, or was that a commercially available tool wherein you used multiple companies on the same sunburst diagram?
Okay, I'll take the second one first just because it's easier. Yes, and I'd rather not, that company really isn't in business anymore. And Patseer and a variety of other companies. But the important thing with any of them is that you recognize how do they do the clustering in the first place, and how can you manipulate it. And then in my opinion, it's essential that you be able to do call-outs, the colored dots. If the system doesn't allow for you to say, okay, I want to highlight this one and this one, whether it's two companies or whether it's a progression over time, whatever it is, that's where you really get the value of those. And so that particular spatial concept map I'm pretty proud of because I put a lot of effort into it. I chose very specifically the type of material it was going to analyze. I worked on the stop word list to make sure that it was fit to purpose. And then the results were compatible and actually reinforced what I got from other types of analyses. Okay? So your first question, giving credit to the people who are working on certification, it's tremendously difficult. And they're trying to do it for the most part with volunteers, which I think is going to be an even bigger challenge. And I've written a number of things where I said, well, is that really what we want to do? Do we really want to focus on a test? Okay? Do we really want to act like we're patent attorneys and we're studying the patent bar or the patent agent's exam and things like that? And okay, and even if we did, would the people who write the paychecks actually recognize that as valuable? Okay? And I have real questions about whether or not that would be the case unless the organization that's in charge of doing that changes itself significantly and focuses more on marketing of the profession, marketing the importance of the certification than what they're currently doing. Now, I know it's not dead. Okay? I know that the QPIP organization is continuing to press ahead, to try to create the first exams, trying to expand the grandfathering clauses. So they're doing, I think, the best they can under the circumstances. And I don't think, it's not done yet. Okay, so I think that there's more to come. Do we have time for any more questions, or are we?
I've got a question. So, two questions, but you can answer depending on the time. The first one was on the INPADOC. So what is the alternative system to INPADOC for, do you do it using a code, or do you have any other alternative you suggest? The second question is more kind of general. The question is on I've been in this field for a long time, and it is never mainstream. This is something that people are never thinking that this is a part of something they need as a report, like market research is something that everybody looks for when they make decisions. So what can we do as patent information professionals to move this forward to make it mainstream? So.
Fantastic. So first off, I mentioned the simple families. The EPO simple family, now that there's others. There's certain database producers have their own families. Once upon a time, I talked about this, something called a one document per invention, which was basically if there were any unique US application numbers, you kept those, because the US system is actually designed to say that each patent is its own invention. That's where divisionals and continuations come in. But really, I would say, I think almost all the major platforms now have simple families. Simple families, it's not perfect, but it's much better than Impidoc. Okay, so that's the short answer for that, and we can have a longer conversation if you like. You see, I'm so happy to hear what you just said. We have an opportunity. I mean, name another patent information professional who's ever been quoted in the New York Times or the Washington Post or in Wired. Okay, you can't. Does that mean that I'm somebody special? No. It doesn't mean that at all. It just, maybe I'm a little bit more of a self-marketer. Okay? People accuse me of that all the time. But it's my opinion that a rising tide raises all ships. And if somebody isn't out there waving the flag, we're not going to get noticed. And I want more people to wave the flag. Okay? I want more Indians to wave the flag. Okay? You folks do amazing work. But who knows about it? And how do they value it? And how do they value you? And what are you going to do to change that perception? I just think you keep doing better work than anybody else. And you take a chance. You know, I said, Jawbone is going to buy Body Media. I could have been completely wrong on that. So I don't know how to do the analogy with cricket. I can do the analogy with baseball. So in baseball, they have something called a batting average. Okay? So the batting average is the percentage of the time that the batter is up at the plate and they get a hit. Okay? Or they have an on-base percentage. All right? So what do you call a player that gets a hit 3 times out of 10? They call that person an all-star. They put that person in the Hall of Fame. Okay? Batting 300 is like this mystical thing in U.S. baseball. Okay? 7 times you struck out, or you didn't get on, you flied out, or 7 times you were wrong, 3 times you were right. And it's so hard to get those 3 that makes you an all-star. Don't be afraid to put your neck out. Don't be afraid to make a bold prediction. And the fact that you've backed it up with good analysis, most of the time the things that I suggest are going to happen, happen. And some of that's because the analysis is done, I think, to a very high standard. And I've been in this field for so long, and I know more or less about the technologies that I talk about. And that makes it easy to come up with, this is what's likely to occur. This is what you should do to be prepared for what's likely to happen next. And that's where the value is. Other people can't do that. You can. Yeah, is that one on?
My final question is, in your initial slide, you showed 80% of the output not going for the patenting process, and a lot of not going into the publication also.
Yes.
And this is a big gap existing in the invention market.
Absolutely.
Right. Now, what do you think? What is the reason behind it? 2 big reasons. What do you think? Why are they not going into the patenting process or not going into the defensive publication process or any sort of publication process?
Yeah, I think it's reasonably straightforward. From a business perspective, they don't care. This isn't academia. This is not publish or perish. This is, we're looking to protect an asset. These are business decisions. And therefore, we're going to invest the time and money into filing patents. And we don't really care if it ever shows up anywhere else. As a matter of fact, we'd probably be happier if it didn't. Because patents are still kind of obscure, still sort of difficult to work with. and not used universally. Okay? So you get all the benefit of having an asset with none of the downside that's associated with making something publicly available. So, and I don't see that changing anytime soon.
Thank you.
Well, my question may appear very novice to you, but since you talked about SciFinder, you talked about SciFinder, right? Cache database. When it comes to chemical inventions, I really find it difficult to avoid SciFinder searches, because whenever I do this, say, keyword-based search, I'm not sure that it is 100% complete. Rather, SciFinder is so easy platform that you just type the cache number or feed the structure. It fetches the entire data pertaining to that particular molecule. So my question is that if I have to simplify a search in keyword-based search, what could put me in the best comfort zone that yes, I have achieved 100% search, or at least almost?
Okay. First, a little context. SciFinder was invented because the research that Chemical Abstracts did was that 80% of the questions that chemical researchers had were going unasked. Okay? There was a bottleneck with the existing chemical information profession. And so oftentimes those chemical researchers would rely simply on their own reading and their own networks, or just not ask the question at all. So SciFinder was specifically designed to make sure that those questions got asked and answered, not the full answer, was provided. And that was an amazing opportunity and insight that ended up being very, very lucrative and very, very useful. Now, remember I said, though, that the people that are still doing chemical information retrieval are mostly focused on patents, because the patents aren't quite so easy. When you get into Marcouche, when you start getting into the variances of understanding how the chemical abstracts database is actually built and how salt forms are covered, and various other idiosyncrasies that are completely lost on a SciFinder user, but are essential to the chemical patent information professional. Okay? And so just like anything else, the chemical patent information professional is going to take advantage of 3 or 4 different means of retrieval. You know, they're maybe going to search by common names. They're going to search by registry numbers. They're going to look for compound registry numbers. They're going to look at Marcouche. They're going to do a substructure search. There's 5, 6, 7, 8 different ways that they're going to approach it, and in the end, they're all going to aggregate it, remove the duplicates, and now you've come up with a relatively comprehensive collection. You can't do that in SciFinder.
Thank you. Thank you so much, Tony, for a wonderful presentation on using machine learning techniques to improve patent analytics, and also letting people know about the patent analytics, how it was before and how it is now, and still continuing to do patent analytics, not by button touch, but putting your own inputs on the dots of the map and making it more flexible and tuned to the answers that you're looking for. So thank you once again, and thanks for answering all the questions so patiently.